Okay. Uh, can you all hear me on the coast? I'm sorry. What's that? Okay. Sounds good. All right. So yeah, it looks like officially this class starts at 5:10. If nobody has any issues, we can usually start at 5. Is there anybody that actually? Let's make sure everybody's here first, because today's actually the last day to turn in the. We're supposed to turn in the non-attending things first, so let's do that. Um, and y'all are actually, there's not too many people, but you're all actually registered for 4 different courses here. So there's the students on the coast, there's students here, and there's a lecture and a lab for both of those courses, and then there's undergraduates and graduates at both of those locations. So there's a total of 4 classes. The one with the most people in it is actually the coast, and we'll start with y'all. Okay, it's kind of dark. I can see a few of you, but raise your hand if you can when I call your name to identify yourself. So these are the coast people. It's Andrew Wilson. All right, great. Right there in the middle. Brady Smith. Great. Christina. How do you pronounce your last name again? Seal, just Seal. Okay. You've been in my class before, Thomas Passons. Yep. And Peter Fargo. Yep. What's that? Yep, right in the middle. And Sulin is, yep, okay, I see you back there. Sorry. You've been in classes before as well. So everybody from the coast is here. And then from Hattiesburg, undergraduates, we just have Lance. You're the only one in the course. You're not enrolled in the course yet. Well, it's not on the computer yet. But did you just do it today or something? Okay. All right. Thanks, Garrett. So Lance and maybe Garrett. All right. Now for undergraduates, we have, for graduates, we have two on the coast. Heather, I already saw that you were there. And is it Elida? Oh, but you're up here. But you registered for the coast section. It's not a big deal. Right. Candace just registered you. Okay. You can't attend face-to-face classes? Oh, okay. Well, it's fine with me. It doesn't really matter which one you're enrolled in. I'm just making sure everybody on the list is enrolled and you're enrolled. And then you must be Corey Armstrong. All right. And so you're not a geography student, but that's great. You just became geography. Okay. So you're listed as anthropology and sociology. Okay. Great. Well, it's good to have you. All right. Did you emailed me? Oh, yeah. Now, okay. Now I'm remembering. All right. So good. Got that out of the way. Everybody is here. Everybody raise their hand. Typically, when I teach one of these courses that's up here and on the coast through IVN, there are more Hattiesburg students. This is the first time where I've had more co-students in the course. And I just talked to the department chair about this today. And I said, you know, it's unfortunate that I'm not down there teaching the course from where most of the students are. And he said, well, you're more than welcome to use the van, because I actually don't have a car at this time period. My wife also works on campus, and so she's picked up the kids. So I would need the university van to drive and see y'all. So we're gonna have to see if we can get that worked out. I guess there's already 2 or 3 of the professors that are driving down to the coast because Vicky Tin Brock left. And so I don't know if the van will be available, but if it is, then I will be down there on a fairly regular basis, maybe as much as every other week. If the van's not available, I'll still come down more than I did for most of the time. I come down twice in a semester. So, and then the other thing about this course is it's a course in web mapping. And so it's a lot of it's going to be online anyway. And most of the lectures and the labs will be kind of like mixed together. There's a separate lecture and a lab course. The lecture is only 2 credit hours, but the lab is 2 credit hours, which is unusual for a lab. A lab is not usually two hours. So what'll happen is that we meet once a week on Tuesdays. You know that, and I'll present the topic, and sometimes the topic may not go the full hour and 40 minutes is what a normal 2-hour lecture period should go. It may only go a little over an hour, and then we'll spend more time demonstrating a particular topic in the lab. So the lab, you know, technically we have 4 hours together in the lab, of which 1 hour and 40 minutes of those is supposed to be structured. We should be able to meet that. I'm sure that sometimes it'll get to be so late at night that you'll decide that you can work on it at home or whatnot, and that's fine. So we're not. I think in the course catalog, how late's this class supposed to go? It's pretty late. 10. Yeah, I don't think that normally we'll be here all the way till 10. So what's that? Right. Yeah, and now, I mean, in order to keep contact hours, I don't even think we need to go that long. It's just 2 1 hour and 40 minute periods. So if we go from 5 6:40, we should be done with the lecture almost always around 6:40, sometimes around 6:30, and then take a 15 minute break or so and go another hour and 40 minutes. That would be let's say 6:45, so 7:45, 8, and then I would like to have time where I'm available for questions, which is what the purpose of having the really long lab is. So we're usually talking about 8:20, 8:30 that we'll be done presenting material, and then I'll be available to answer questions. And again, I don't expect all of you to stay around for that time period. And if everybody else leaves, obviously I'm not sticking around till 10, but I'll be available until that time if there are questions and there are people working on things. All right, so that's the schedule. The other thing that I like to do in my courses in the past is to create this is the reason why I'm wearing this weird thing, is to basically record all of the lectures and what the computer's doing at the time. So you're not actually going to see me, but you'll see the computer. So right now, during this time period, it's pretty boring because you've just seen this page. But it is recording the screen, and it's recording my voice, and that's why I'm wearing this. Usually I do this with my laptop, but I got a new laptop, and I thought that my hookup that would normally allow it to transmit through the system, you know, like one of these little dongles, would work, but it has a different standard, and I can't plug this into the side of my machine. So that's why I'm wearing these, because this other computer that I've rigged up does not have does not have a way to record sound. Okay, so it's recording the sound. All right. So let's look. First of all, I'm going to use Blackboard. Okay, I'm relatively new at using Blackboard. I've used it for other courses, but this this should work. Okay. This is like the worst time to teach in this lab, by the way. The lighting changes constantly. All right. So obviously you don't see all this, but you should see one that's called Fall 2016 Cross List Geography 469, 569, 469 Lab 569. So I've put it all into one course. So it is concurrent. Yet you do have to be enrolled, and everybody is, but you do have to be enrolled in both the lecture and the lab. It doesn't. This course, like I said, we're going to mix. We're going to kind of blur the line between the lecture and the lab. So you have to be enrolled in both courses. It doesn't work to just be enrolled in the lecture or the lab. If you did, for example, if you did want to do that for some reason, I would still recommend that you attend both the lecture and the lab. Okay, so let's look over the syllabus really quickly, and then we'll get into what we're going to cover today. And I don't anticipate today that we'll even be here as long as normal. I have a little bit of take-home assignments for you today, rather than a formal lab. Okay, so this is called web mapping. Who here has experience creating web pages? Any experience creating web pages? Some experience? You have some experience creating web pages? All right. Like, so who here has wrote their own HTML before? Kind of. Yeah, many years ago. So we're gonna do some of that. I mean, we're gonna do actually a fair bit of that in this course. Okay, we're gonna learn about that. We're also going to learn about just the underlying fundamental technologies that are used to do web mapping. Okay, but we are going to get into writing code. I'm not going to say this is going to be a computer science level class, but we are going to write some code. So these are some of the things that we're gonna learn about. Yeah. So one, got the two main purposes. One is the importance of I should have said web map services, and then give you some experience making web maps. Okay. So those are the two things we're going to do. Now, one of the things that we're going to do that's interesting in this course is that we are going to hit or discuss free and open source software for doing internet mapping or web mapping. Okay, we're going to hit that just as hard as we talk about commercial products. And you know, I don't research everything. I do research web mapping. It's one of the fields of GIS that I participate in, that lots of my funding comes from. And so I don't know this for sure, but it does seem like GIS software, particularly online web mapping software, has a lot of participation in the open source community. Okay, a lot of people use and share their code. Okay, and so that's one of the reasons why we talk about it. Is because it gets used a lot. Okay, so we're gonna talk about that, and today is probably the day we're gonna hit that the hardest. Actually, talking about free and open source software. Okay, all right. So this course does not have any prerequisites, but we are going to jump in, starting even a little bit next week, starting and using technologies that allow us to create dynamic web pages that change when we do things. You click a button, something changes. And eventually we're going to turn that into maps. You click a button and some GIS analysis happens, right? Or you click on the map and you get some information about what's there. Okay, those are the kinds of things that we're going to do. So it's helpful if you come into this course with some experience with HTML, stands for Hypertext Markup Language, and CSS. CSS stands for Cascading Style Sheets, styling websites. However, it's not necessary. We are going to get into that a little bit next week. So some of you that do have some experience with HTML, you might be a little bit bored. Might be a refresher for you. Okay, it'll be fun, hopefully. So I do recommend that you do this. In fact, you should look at these websites for HTML and then for JavaScript before we meet next week. Those are your first homework assignments. And I'll kind of walk through what I mean during the lab period of today's course. We don't really have a formal, there is an assignment, but it's not a lab. So after we get done just talking about things today, I'll introduce these two websites and we can do that. All right. And then I have another website, another place that you can look at to start exploring something that makes JavaScript a little bit easier, a little bit simpler, called jQuery. We are going to use that. And then finally, there's a JavaScript library. In other words, if you were going to create your own web map from scratch, okay, think about it, from total scratch, you'd have to know a lot of things, and we'll get into exactly what you'd have to know today. That's what we're going to talk about. But it would be a complicated process because, well, first of all, maybe we should just get into it a little bit right now. Okay, so if I go to Google Maps, everybody's been to Google Maps, right? Everybody's been to Google Maps. Okay, there's Google Maps. Anybody not been to Google Maps before? Right? You use it to find out how to get to different places. It's on your phone nowadays, right? Okay. Now, what do you suppose this is? When I go like this, what's actually moving? What is it that's moving on the screen? Yeah. What are things that you, okay, when I go to a normal website, I don't know, usm.edu. I go to usm.edu. There's basically only two things on this screen. Okay? Like this is text, right? And then how do you think this got here? This picture of a reel and the picture of the dome. Okay, how do those get there? What are those? Text and images or pictures, right? There's only two things that you can put on a website. There's actually a few more. You can actually draw. Nowadays, you can draw. You can actually ask it to draw pictures. Okay, like a pen and ink style thing. Okay, I want this. I want to draw a little star shape or a triangle shape. Okay, so you can draw vector graphics. But basically, up until recently, you could put two things on a web page. You could put text on a web page. You could put pictures on a web page. All right, and so that's in a large part. That's still what the internet is all about, right? So when I move this map around, here, when I do this, I'm just moving a picture around. It's a picture and it's being moved around. Now, when I zoom out, what do you suppose is happening? I wish I could hear better. What was that, Heather? Was that you? Yeah, exactly. It's requesting another image, another picture. Okay. And then there's all sorts of complicated things that are going on to like kind of ease between the pictures gently. Okay. But I'm sure you've been to websites. Maybe if we just go to like ArcGIS Online. So here's ArcGIS Online. I can do the same kind of thing here. Lots of these websites are, okay, so yeah, see how when I zoom in there, the easing between the different images isn't quite as crisp as it is on Google. It just kind of fades out to the higher resolution version. Okay, but all that's basically gone on is that when I zoom in, I make another request back to a server for another image. I mean, I don't make it, but the computer program makes that request. It says, okay, hey, I need a different map because the extent has changed. Okay, I'm changing the extent. All right, so going back to this, the Leaflet is a library that basically helps us to do this sort of thing, to do the kinds of things you do with a map. You zoom in, you zoom out, and it automatically makes those requests to the servers that are generating these images. So the servers are generating these images, and you're consuming those images on a web page, right? So we're going to learn about that as well. We're going to talk about it a little bit more today. All right, before we do that, let's just go over the tentative schedule here. I'm going to change this up. I've only taught this course once before, and we're going to change up the order that I'm going to do things in a little bit. So previous, I kind of started out focusing on the server side. And now I'm going to start out focusing on the client side. In other words, the web map itself. And then as we start consuming different things, we'll learn about how those services are generated. Okay, so we'll start off making web maps that don't use any services, or that just use very basic services like Google Maps and ESRI maps that already exist. Start out using those kinds of maps, and then we'll put different layers on the maps that other people have already created, and then we will do some vector work. So we'll like actually, draw our own little pins for things that we want, and then we'll start consuming services. Okay, we'll start using maps that we created. And one of the great things about web mapping is oftentimes it's been referred to as a mashup. You can take some data from an existing source, like an existing base map, like Google Maps or ArcGIS Online, and you can stick your own data on top of it. Okay. All right. All right. So that's the schedule, and then at the end we'll talk a little bit about databases and how they fit into web mapping. We do have a project that's required in this course. So at the end, you're going to present a project. Okay. I might seem I wish this wasn't so hot on my neck. That might seem a little daunting, but you have all semester to do it. And we're not talking about creating, the next Google Maps page that has the ability to navigate in between locations. So this is, what I want you to be able to do is walk out of here and have created a web page that does something simple, allows users to see some geographic data and to analyze it or to get some feedback. So it needs to be dynamic. Okay, you can't just have a map that doesn't do anything. You need to be able to do something with that. And so that's pretty much the only requirement. And it's a little different for undergraduates versus graduates. The undergraduates are just going to create it and write a really small write-up, like a little page write-up about what it does. The graduates are just going to need to do that and have a little literature review related to your project. Okay. Okay. So that's the grading. This is the stuff that's all required. Okay. All right. One of the things that, yeah, okay, I did put it in here. All right. One of the things that I want you to do is when I ask you to turn in an assignment, unless I make an exception, like today's assignment is actually going to be on Blackboard on the forum there. But if I ask you to turn in a digital assignment and I didn't specify it's Blackboard, please email the assignment itself to ghy.gis@gmail.com. Okay. The reason why I'm using that Gmail address is so my regular email address doesn't fill up, because we're gonna be creating information, and oftentimes there'll be data associated with it. And it could be several megabytes worth of information. And if I had everybody email george.raber@usm.edu for that, then those assignments would get to, over time, they would clog that box up. However, do not email me at that email address to answer a question, because I won't answer a question there. Not because I don't want to, it's just I don't go on to grade that often, or maybe once a week. It's not often enough. I want to be able to respond to your questions very, very quickly. So if you email to that, I don't check that every day. I'm constantly checking, George, not constantly checking it, but I get it on email on here, and I can look it up and say, oh, they emailed me, and I can reply. All right. Okay. Let's see. That's good. Anybody have any questions about that? All right. There isn't a textbook for this course. There are readings online, and we're gonna start with the first one today. So I'm gonna close this up. All right. Oh, that's the syllabus. Okay, so I'm gonna go down to course materials. I'm not gonna, for this course, I'm not gonna have a lot of PowerPoint presentations. Okay. Probably only a few. Most of the material that I present, I can't hear them if I do that. Most of the material I present will be from the reading assignments, and then I'll actually, go to websites and I'll also be demonstrating things, and we'll proceed like that. Okay. All right. But there will be a reading assignment, which is here. All right. Okay. So first off, I'm just gonna talk about what's in this reading assignment and go over the things that I think are important. But you should still read over it on your time. So I kind of already introduced a few concepts. Okay, we talked about Google Maps and ArcGIS Online. So I want to go back a little bit further than that, though. Okay, so the start of web mapping. Originally, web mapping was just serving up static images. Okay, so if you wanted to put a map on the web, you could put an actual, you could go into ArcMap. Well, at the time we didn't have ArcMap, but you could go into your GIS software and export an image and put that image on a web page, because almost since the web's earliest days, we've been able to make images be on web pages. right? But they were static, okay? So that progressed from that to very early map server software. And one of the examples of that is a Tiger map server that was used to display census information for census workers. Another example would be the very first tools for just basic navigation, like MapQuest had a version. And one of the things that made those sites a lot different than today's web mapping programs is that typically they had arrows on all four sides of the map. And the map itself didn't do this. Sometimes we refer to this as a slippery map. The map didn't do that. Okay, anybody remember those days when there's just four little arrows right here? And if you wanted to go to the next map up, you press the button. Okay, and the whole page reloaded. Okay, and then you got the new map, but everything about the page reloaded. Okay, right. That was before a very early web. I mean, sorry, that was before a technology known as asynchronous JavaScript and XML, or for short AJAX, was really invented. Okay, or utilized. So what that technology allowed people to do was to have a web page, and then the way that it first started, who knows what a frame is on HTML? Do you know what a frame is? Okay, what's a frame? Describe what a frame is.
Just breaks up the page into segments, and the HTML code each side of the frames. We have one overarching HTML code, we have text. 127 frames, broken up by not really pixels. We would set it up so we have different sizes.
Yeah, yeah. You can display two different web pages on in the same browser window. So, by the way, so we're getting all the technology. This is a web browser. Everybody knows that. But other web browsers include Internet Explorer, Netscape Navigator. Chrome is the one I'm using here. And a frame just allows you to display more than one web page on the same website. Okay, and so the very first implementations of this AJAX, or asynchronous JavaScript and HTML, were that what you could do is basically have a separate page that was hidden, a separate frame that was hidden. Okay, and what the JavaScript code was doing was saying, okay, when they hit that little button up there, or sorry, not when they hit this button, when I move this like this, have the other page load the new information that I need, and when it's done loading, then put it onto this page in code. Okay, so that's how this gets done. It's actually the same technology that allows Gmail to work. Okay, I'm not going to pull up my Gmail because then it'll be on video. You could see all the people I Gmailed. But you know, when you go to Gmail and you click on one of your conversations, or whatever email client you use nowadays, but Gmail was the first one to use this. When you click on it, it loads it up and it doesn't refresh the whole page. It just loads up that conversation. So it makes a request out to a server, and the server sends that information back. And nowadays it doesn't have to use an invisible frame anymore, but it initially did. And then it takes that information that's been returned and displays that somehow. Okay. So this is a technology that gets used in web mapping a lot, but it is a technology that actually drives the modern web, is having services that fulfill AJAX requests. Okay, all right. So I skipped ahead a little bit, but one of the other inventions, okay, one of the other cool things was that cartographers actually started getting more involved in GIS. Okay, and that happened about the same time. So we're talking about 20 years ago or so. Okay, initially, if you were to walk around in a geography department 20, 25 years ago, a lot of the maps would be fairly hideous because, you know, GIS was being used by a lot of people, but not by a lot of designers. Okay, and so we had people creating very pretty maps and doing that for the web. And so, what the marrying of these two technologies allowed for was things like Google Maps. Google Maps was really the first big website to use this technology that basically, and this is another one, ArcGIS JavaScript API, that basically allowed us to have very responsive maps because of AJAX and requests to services, as well as having maps that were pre-rendered. So all of these, another advantage to all of these maps is they're all pre-rendered. Okay, how much space do you think that takes up on disk to have the whole world pre-rendered like this, where you know, each of these tiles. This is actually something we're going to do that I actually showed later in the lecture, but let's look here. If you go to this little button right here, the little drop-down guy, and you say More Tools, and you say Developer Tools, and you switch to Network, now when I zoom in, it'll actually show you all of the things that were requested asynchronously. These things were requested asynchronously, and I can open them up. So, for example, I can right-click on there and say, open a new tab. And that's a pretty boring tile, right? It's just so let's open up a different one, because this one looks like it's got something. Open in new tab, okay? So this is showing you that, in fact, what I'm saying is true if you didn't believe me. This is one of the requests that's been made. And this tile wasn't drawn by the server. The server didn't say, "Oh, you need that tile? Well, let me go create that JPEG for you." Right? It didn't do that. Okay, Google actually pre-created all of these tiles, and that's why it's so responsive. Okay, so one of the neat things that was done when web mapping was to separate out base information that could be pre-rendered, pre-created, from thematic information that might have to change if you wanted it to be responsive. For example, if you had a layer that represented all the earthquakes that happened over the last 24-hour period, I'm sure there's a website that has that. Okay, all the earthquakes that happened in the last 24-hour period. Then you could have just that information needing to be drawn by the server dynamically, or being created on the fly in some other way. Okay, so that is one single tile. So when I say in the lecture here, in the reading material, when I say many sites begin serving out pre-cooked tile images, that's what I'm talking about. Okay. All right. So yeah, that eliminated the it says ubiquitous and annoying blink. Basically, it eliminated the page reloading. Right. Okay. So we already talked about that. Okay. So one of the things to take home from that might show up on the test is that AJAX and better cartography, they basically allowed web maps the ability to be more responsive and to well, I kind of threw the cartography in with the question, not the answer, but this allowed the cartography to get better. The fact that maps could be pre-rendered or pre-tiled. Okay. All right. Okay. All right. So, hold it. Let me do a sound check here. Make sure. Can this still? Yeah. Okay. I'm gonna try to just put it right here and not walk around so much. Otherwise, I'm going to get asphyxiated by this headset because it's quite tight. it's on your ears, it's okay, but then I couldn't hear you all down the coast. So I'm gonna put that right there, and I'll probably knock it off by accident at one point, but it'll be there. All right, so the next thing that, well, it's really involved in what I just talked about is the importance of web services. So static maps are oftentimes already exist. They're drawn on the static tiles are drawn already on the server. So when you move the map around, you're basically just saying, get another tile for me, get another tile for me, get another tile for me. So do you think that that requires very much processing power on the server? No, it requires a lot of hard drive space. I forgot to actually answer the question. So this map right here for the whole world is probably terabytes. Okay, because when you zoom all the way down in, think of how many individual maps there have to be. Okay, zoom all the way down in here. Okay, I've got all of these maps. Okay, so I've got a map just for this little portion of the world, the intersection of 23rd and Kenneth Avenue. So think of how many other maps there are. Now, there's a lot that are exactly the same, and there are tricks that the computer can do to not store redundant information in the middle of the ocean. Okay, but for all the land, that's a lot of information. So it could be terabytes of information. So tiled map services like this don't require a lot of processing power on the server. They just require a lot of storage space. So when a request is made, you get a map back. It's pretty much like any other web page. Okay, it's not complicated. Now, what happens if you wanted your your web mapping page to do something cool? What if you wanted it to let the user pick a point and tell you how many people lived within that circle? Maybe that's not that cool, but can anybody think of another website that does something that you think would involve geographic analysis? Well, like a more specific example, I'm sure there's I'm sure there's a USGS website that shows the earthquakes, the most recent earthquakes. Let's just see if there is. That's right, recent earthquakes map. Okay. Latest earthquakes. All right. So here's a map. It doesn't look that exciting, but it's a map that shows the most recent earthquakes. Kind of interesting that we've got some in the middle of the country here. And I click on them. All right. I can get information about them. This is the kind of, in fact, this is a pretty simple website. This is the kind of website that I'm talking about for your final project. Make a website like this. Okay. You can click on the maps and get information. That's a little bit of a sidetrack, but that's what I mean for the project for this course. It could be on a different scale. It could be buildings on campus, things like that. But this one's pretty straightforward. It doesn't really involve much actual geographic analysis, right? I'm just clicking on a point and I get information about that point. But let's say I click on a point and I could get a record of all of the earthquakes or maybe tornadoes that happened within 500 miles over the last 2 years. That's something that would require geographic analysis, right? So in the GIS world, I would have to do some sort of overlay option. I have a layer, okay? And so what that would involve for the web, okay? Well, first of all, what would that involve on a computer, on a PC, in ArcGIS? Let's say I had a layer that represented tornadoes, and I wanted to ask the question, which tornadoes happened near Hattiesburg? And I define near as within 200 miles of Hattiesburg. So how would I do that in ArcGIS? I could do an intersect, right? I might have to do a buffer first if I didn't have the 200 thing, right? So I'd have to like have a layer that represented Hattiesburg, or I have to like actually click create a new dot on Hattiesburg. And then I could buffer Hattiesburg, right? Okay, using our GIS terminology, I could buffer Hattiesburg. And then I ended up with a polygon that represented the area that's what? I already hit it once. 200 miles of Hattiesburg, right? Then I could take that polygon and do what you said, intersect that polygon with the points, and I would have all of the tornadoes that were within 200 miles of Hattiesburg. Did I say miles? I forget. I switched like units. Hopefully, I should be using kilometers, right? But anyway, let's switch that up for the internet. Really, nothing different changes. All right. So, what a web service does is that when I make that click, it takes that XY location, passes the XY location to a server. And then the server from that point acts pretty much just like ArcGIS. It has to run some code. And then it takes those points and sends them back down. Now, we'll learn in our class, there's lots of different ways to pass that information back to what we're going to call the client. The client is the web browser. I could pass it down as an image, just another picture with the points on it. Or I could pass it down as a bunch of XY locations, and then you, as the user, would be responsible for symbolizing and putting those on the map, drawing them basically. That's one of the first things we're going to cover is how to just put points on the map, or lines on the map, or polygons on the map. Okay. All right. So that is a web service. Now, you can imagine that this sending information and receiving information wouldn't work very well if there wasn't standards. Okay? And so there have been several standards that have been created, and these standards are always published by somebody. Sometimes they're marketed, or they're shared as what we call open source standards. In other words, a body comes together and says, okay, we're gonna make a standard for creating web maps. So when somebody wants to request a map, these are the things they have to say. And when somebody wants to get a map back, these are the ways that we're going to give that map back. We're going to give you an image, and we're going to give you some data. Okay? All right. Now, one of the cool things is lots of these libraries that we've talked about, or that I've talked about already, like Leaflet is the one we're going to use for this course, already abstract it. So you don't have to know the exact way that you're communicating with the server, but because of the standard, you could say, make this type of request for this map, and it takes care of turning that into a request that the server understands. And then when it gets the response back, it takes care of turning that into something that your web map can use. But it's because of the standard that you can make that request and get that response. So this is basically web services in a nutshell. Not just internet map services, but web services of any type. So we've got the client right here, okay? The client, and the server. The client is where the web browser is running. The web browser makes the request. Something's done. Usually, a web map service draws a map, an image, and then that's passed back to the client. We can also have data services that are providing data back to the client rather than just images. So this one is actually right here. So if I hit this guy and press enter, this is a weather map. That's what this is. It's a weather map. I don't even know exactly where it is. And this is running a particular type of map server called a web map service, a WMS. And it is an open map service. In other words, it uses a standard that a bunch of people got together. It's not created by a company. It's an open map service. And there's a few things that I can change on here and that you'll be familiar with. Look over here. Oh, all the way over here, I've got this bounding box. I can modify the bounding box. What do you think that's going to do? Like, let's change this number to, let's change it to something fairly dramatic. Let's change this number to 8. Enter. Well, that didn't really change much. It's hard to see. I'm only shifting the map around a little bit, but those parameters over there are basically changing the box, what you're getting, the rectangle that you're getting, okay? And so when I go to a website and I pan around, instead of getting a new tile, so that is right here in ArcMap, instead of getting a new tile, I'd be requesting an entirely new map, because this map is being drawn dynamically. It's the current weather, so we can't just tile the whole world because the weather's changing all the time. Okay, I think that I can in ArcMap, I can, in ArcGIS Online, I'm pretty sure I can add. Maybe I have to sign in first. Sign in. It's going slow. Yeah, there we go. I just hit modify map, and I'm going to add a layer from the web, and I have ArcGIS ESRI is actually pretty good. They've become better at allowing for these open standards. Okay, because the open standards are published, anybody can implement them. And so even though this is a product that's created by a company, I can add a WMS. OGC stands for Open Geographic Consortium Web Service, OGC web service. So I can add a WMS web service, and I could actually add this URL here. And I don't think it wants any of this other information. I think it just wants that. Let's see if that works. It's taken a few minutes, but if it doesn't seem like this is super fast. In other words, they've got a pretty slow computer that's drawing that information. It does say it's loading. All right. I'll just let it hold on for a second. Go back to the lecture. Okay, but as I pan and zoom, ArcGIS Online, that web map would take care of changing the other information here, such as the bounding box. The other thing that's on here, this thing right here that says EPSG, that's the projection. Okay, this code right here is a code for the most common projection that you can see on the web. Has anybody noticed that? When you go to Google Maps, okay, and when you go to ArcGIS Online, and you look at a map, Okay. Same projection. Okay. Everybody know what projection does that look the most like for those of you who are geographers? Or for those of you who might know? It's an old, what's that? Yes, it's a Mercator projection. Very good. All right, it's actually a specific type of Mercator projection that assumes that the world is round, perfectly round, spherical Mercator. And it's nowadays more often referred to as web Mercator, meaning that it's the web. And just like these other open standards, it's become a de facto standard for sharing data on the internet. So because Google Maps decided we're going to adopt this map projection to display the whole world, everybody eventually decided if we all do the same thing, then we can make we can make mashups, we can make maps and put our data on top. Okay? So I would say about 90% of all geographic data online is shared in this projection. Okay? There's some weaknesses to that. I mean, if you're just trying to show a little area, like let's say you were just trying to make a map of Kingston, and you tried to calculate areas, those areas wouldn't be comparable to just making a little map of some other city in the other part of the world. Because what happens with the web Mercator projection? As we go further north, what happens? Is Greenland really that big? No. Okay. So we can't use this projection to calculate areas, and oftentimes, what's done is that even though the data is shared and displayed in these projections, when we go to ask the server to provide an information about area, we reproject that set of information to a different projection. Okay. Before the information is shared back out. See if this ever loaded. Maybe that's not going to work. Maybe it just wants that. Sorry, I should have seen exactly what it wanted instead of trying to guess here. All right. All right, so we already talked about tiled services a little bit ahead. We talked about tiled services first. Then we talked about what we're going to refer to as dynamic map services. Okay, dynamic map services create maps on the fly, and those require a computer with more processing ability and less space, less hard drive space. So the map service that's providing this weather information, it's gone now. We've got like too many tiles. The map service that's providing this weather information, you want a machine that can actually handle drawing that all the time. Every time you pan or zoom, you're gonna actually cause a program to run on the server that's going to create that information. All right. Okay. All right, let's go to this website here. Copy. So I went to Portland this summer for a conference. And I rode around on TriMet a fair bit. Okay, TriMet, this website here, is created using only open source technologies. It's kind of cool. So there's some WMS services that are running that are creating the base maps, and then there's some other information that are showing the different lines here. But if I do the same thing where I go to this little guy and then say more tools, developer tools, and I go to network again. I'm already on network. And I zoom in, I can see the data sets that are being requested. And these are tiles, just like the other ones. Let's see if there's any WMS. it gets created. Nope, it just looks like tiles. So you can see those individual tiles. Okay. Actually, what this says is this kind of developer tool will be important to you later in the course. So being able to open the developer tools and looking at the network, and also later the console. The console will allow you to kind of see bugs in your code that's written. Okay. All right. First time I took this course, this was the book I used a long time ago. And Dr. Plew was actually my undergraduate advisor. Okay. So we talked a little bit about the structure and how web mapping works in basic terms. And really that was an introduction. We're going to dive deeper into each of these concepts each week. Okay. So we're going to start off talking about the client, and the client at first is just going to be making basic map requests to tiled map services. Our clients are. Then we're going to make basic requests for data. First, we're going to use data that's already on the client, and then we're going to progress and get into using other web map services and data that's stored in databases, and then we're going to tie it all together. Okay, so that's what we're going to do. All right. Now the second part of this course is, the second part of today's lecture is talking specifically about free and open source, or FOSS. Okay, it often gets called FOSS. And then there's actually a conference that happens every year that's just about free and open source software. That's a cool conference. I took a graduate student, and he and I presented at FOSS up in Portland. That's what I was doing in Portland. We had a great time. So there is a very active open source community in GIS. This course won't really promote open source over the other, but it gets used a lot, even in production environments. There are, you saw, for example, the city of Portland is using all open source software to make this web map. In other words, the software itself didn't cost them anything. Okay. All right. So we're going to talk about open source software. We all know that when I say software, I'm talking about the programs that run on the computer. Okay. You can't see or touch or taste it. It exists as code on a computer. Okay, that's what we're talking about. There are several different models for sharing software. Okay. One of the models is that people spend a lot of time creating software, okay, and they need to be compensated. And so a typical model is that I create software and I charge people to use it. That's commercial software, okay? And that's one way to make money using software. Another way is that if I create software, I can share that software with other people, and other people can help me to make the software better. And we can all contribute to making this fundamental building block of software better, and then we can use that software in some commercial product where we make money. Okay, so when you go to a website that has a map on it, lots of times the map itself isn't making the money. Okay? It's part of the web page, and so these things that are free and open source sometimes we mean that it's actually free. And sometimes free can mean that it's without restriction in terms of its use, right? And so sometimes they make the distinction, and I never understand exactly what it means. But sometimes in the free and open source software community, they mean free as in freedom or free as in beer. Like, does that mean that I'm getting the beer for free? Like, anyway, hey, we got free beer over here. That means that, I guess that means the beer is free. Anyway, I don't understand exactly what it means, but sometimes people say that when they're trying to distinguish between free and freedom. All right. So there are different licenses associated with free and open source software, and we don't spend a whole lot of time getting involved in those. I'll just basically say the main difference in terms of free software is that some people argue about what this term free means. Okay? So does free mean that the software needs to remain free as in beer, or free as in it's free for everybody, or does it need to remain free as in you can use it in any way you want? And those concepts actually conflict. Because if I'm truly free to use the software anywhere I like, then one of the ways that I probably want to use it is to use it in some way that will earn me money. And then it becomes commercial software at that point, right? Okay. But then it's no longer in this realm of free software. And so it's no longer free as in it's free for everybody. And so there are two main types of free and open source licenses. And it matters if you end up using these types of things in your company or in your life later on, okay? If you use what they call a permissive license, so there's a few licenses that are permissive, like the MIT license, the BSD license. Those are permissive licenses, and you're not going to have to memorize any of those on the test. Those are permissive in that you can use the software for anything you like, pretty much. So if you want to take that software and you want to modify it and create your own software that you are using to earn money, that's okay. It's part of the license. However, if you want to use a license, if you want to use software that's called, sometimes they call it copyleft licenses that are more restrictive, in that you can't use the software for anything unless you then take your changes and also make those free. And the GPL is probably the best example of those licenses. It's the licenses that lots of Linux distributions are that use. In fact, it actually stands for new NEW public license. Okay, so those are the two different types. I don't even know if I talked about those, but I did want to mention those things. Okay, so there are differences in that world. Now, what a lot of companies, regardless of whether they're choosing a permissive license or not, a lot of the ways that these companies that contribute to open source software make money is through consulting. So they'll make a great product, okay, but these tools are often just that, tools. And so in order to make a finished product like this, you would still need some expertise, like the kind of expertise we're going to learn about in this course. You'd still need some expertise to do that. And so they get hired to make things with these tools that they create. And so that's why in web mapping, they're really more popular than they are in the desktop world. In the desktop world, desktop software, it either works or it doesn't work, and it sits on everybody's computer. Everybody installs it, okay? occasionally we want to customize it. But really, we kind of accept the feature set that it has. And so commercial software is much more prevalent for the desktop, okay? But for the web, there's already so much tinkering you have to do to make a successful website. There's lots of customization that you need to do to make your website successful. Because if everybody just went on ArcGIS Online and made their web map, it wouldn't be as cool. There's no way to automatically make a customized web map for the way you want it. Okay, I mean, we can get closer and closer to that point, but it's still a long way from that. Okay, that you can just sit down, click a few buttons, and create a web map. All right. So since they often get customized a lot, there's a niche for these companies to create these tools and then have consumers utilize the tools. The nice benefit is that if you're a tinkerer, you understand how it works, you can do a lot of very powerful things for not much money. Okay? There's lots of different companies that are involved in this. The presentation that you're going to have to watch for today's lab is the leader of one of these companies. His name's Paul Ramsey, and he's going to make a presentation. He's going to do a little bit better job than I am right now of making a case for free and open source software. Okay. All right. So here are some of the benefits for free and open source software. Okay. First off, obviously, it can be a lower cost solution, because if I spend time learning about it, and time is money, but if I spend time learning about it and I invest in it, I don't get charged over and over and over every time. Once I figure out how to use it, I can use it lots of different times. Is that true of commercial software? Most of the time, you have to install or buy a license for every computer that's running that software. Okay, so that's one big thing. Usually, there's more flexibility with software. The software is designed usually by teams of people that are distributed, and so by their very nature, there's lots of flexibility because these people are working piecemeal to create this software for you. So the ability to get a bug fixed or the ability to change a certain thing exists more often in free and open source software. Okay, interoperability. Interoperability means the ability to share particularly data and other resources between programs. Okay, and this has to do with standards. So when standards get created and they're free and open, they allow you can plug in software A or software B, and it can use the same data because there's an open standard for how the data needs to be shared. Okay. All right, now security is probably debatable, but it is true. We have a couple people that have gone down to Stennis and started working down there, and the government is not shy about using free and open source software when it fits the need. Okay, they will buy commercial software, and if the software is developed right and built correctly, it will have security, just like other things. I'm not a cybersecurity expert, but that was one of the examples that's in the lecture here. All right. Ethics. Ethics is meaning that some people actually consider using open source software as an ethical question. Okay? So, and this is one of the things that's exciting to me about it, is that as an academic, it makes it actually easier to participate in the development of the software when it's open source. And so it kind of makes it so that it's more democratic, and it contributes to the expansion of collective human knowledge. So it's one of the great things that, because I like to tinker, and so one of the great things, I don't know if I call it ethics, but it is something that is an advantage. All right, some of the challenges of free and open source software. One of them, we don't call these disadvantages because sometimes they're not true of every single open source software package, but one of them could be usability. They're designed for people to get involved and to tinker with. They're not necessarily designed as an out-of-the-box solution where everything just works. Okay, so sometimes it takes, there's a learning curve associated with using free and open source software. Okay. Now, in my own experience, I found that once you take the time to invest in that, that learning curve really levels off, and things become easier in the open source world in a lot of cases because you can see everything. You know, okay, this feeds into this process and this feeds into this process. You can see it all rather than, well, in ArcGIS, when I press this button, it creates this web service. I have no idea what just happened. I don't know what's going on in the background, but and it seems like every year ArcGIS creates a new way to create a web service, and it's making it more and more of a black box. But that black box does work most of the time. Okay? I use ESRI products all the time. I'm not making the argument against it. I'm just saying that it's neat that we have so much free and open source software in this realm. Okay, let's see. Documentation availability, that's a challenge. Sometimes people will write software and they'll say, hey, isn't the software great? But there's no way to figure out how to use it because they didn't document it. This does happen. And oftentimes, the documentation comes much later than the software package itself happens. So that's a challenge. But as a drawback, I mean, as a counter to that, there's oftentimes more people chatting about it online. Okay, so sometimes you can join a community that is helpful. And then probably the biggest challenge is support availability, and that's the big difference. When you go with free and open source software, almost always you're paying for, if you want support, you're paying for it. Okay, with commercial software, you buy the product, and part of the product is that they support it. You can call them up and ask them questions. Sometimes you're limited to how many questions you can answer, but you can always ask the question of commercial software because you paid for the product. You better be able to answer my question. Okay, with free and open source software, there's not somebody that's financially responsible for answering your questions unless you pay them to answer your question. Okay, so that's actually where the money is made a lot in free and open source software, is through support and consulting. Okay, and then the last thing here are some contested points. In other words, these points are, some people say it's better in commercial, some people say it's better in open source. Okay, I already said that in my view, usability was contestable, but anyway, the breadth of features. Okay, you're going to watch this Ramsey video later that it's talking about here, but the breadth of features, it depends on whether or not you consider having developmental features that may not exactly work being more breadth of features, because sometimes that'll happen in open source software, or whether or not you consider commercial software to be better at that. Okay, quality and technical superiority. I can tell you right now that in my view, they're about 50-50. ArcGIS is not exactly known for not having bugs. Okay, you get problems with ESRI software just like any just like any other software, free and open source software. And then innovation, I believe we kind of rolled that into some of the other talks there. You can read through that. Okay. Now, free and open source software is used in lots of different venues. Linux operating system, an example of an operating system. What's an operating system? What's the operating system on the computers you're sitting in front of? Windows, exactly. So Linux is a different operating system that is a free and open source version. Okay. All right. Apache web server. What's a web server? Yeah, exactly. So back up at this diagram right here. Whoa, way up here. This computer right here is actually running a program that's waiting for your requests. And that program is called a web server. And so Windows comes with its own web server called Internet Information Server, IIS. It comes on all, you can turn it on any Windows computer. If you want it to become a web server, you just have to turn on IIS and it'll be there, okay? But Apache is a free and open source version. The free and open source version I use more, I don't know why I didn't put it on here, is called Nginx. So that's another one. Okay, we're going to talk about databases in this class. MySQL is an example of a free and open source software. Probably a bigger one in GIS though is called Postgres, right here. Postgres SQL. Okay. What's the equivalent of that in the, what are some commercial big proprietary database software packages? You know? What am I talking about? You probably don't deal with these on a daily basis. These are installed on servers usually. Oracle, exactly. So Oracle, what's that? Oracle, good. SQL Server is the Microsoft equivalent. Okay, those are both proprietary packages. There is a GIS equivalent. Open source equivalent called PostSQL. And the reason why this is so used so much more than MySQL in GIS circles is because the GIS extension called Postgres is developed, and we'll talk about that. That's not till like the later part of the course, but it's pretty cool. All right, so FOSS is used in government, and FOSS is used in web mapping. That's what we're going to talk about here, and we're going to use free and open source web maps. So we're going to use Leaflet a lot for the client. We'll kind of pull this together over the next few weeks. All right. I'm going to finish with this one. I'll let you guys look at this diagram separately. I kind of just went over it, but we're going to finish with this one. I've used the term open standards here a few times, but recognize that there are a few different things when we say open standards. The open standard could be applied to a few different things. One is that we could be talking about open data formats. And data itself in GIS often is either points, lines, polygons, or a raster, which is an image, right? And so an open data format is a format for storing data. Some examples of open data formats are KML. Who's used KML before? Okay. KML didn't start out as an open data format. What's KML used for? Yeah, Google Earth uses KML. Anybody know what it stands for? Yes. It stands for Keyhole Markup Language. So Keyhole was a company Google bought. So it wasn't, Google Earth was originally a project called Keyhole, okay? And I don't know exactly why it was called that, but that's what it was. And so keyhole markup language is a language for sharing points, lines, and polygons and images in Google Maps, in Google Earth, sorry. But now they open sourced it. Okay, anybody can use it. It's an open standard now. GeoJSON is one that's a little bit more powerful, and we're actually going to get right into using that one. Okay. GeoJSON is another example of a way to share GIS data. Now, in the desktop environment, there are some that you've heard about, shapefiles. That's actually was one standard that was invented by ESRI, but now is open. Okay. All right, now the difference between shapefiles and things like KML and GeoJSON, and we'll get into this a little more next week, is that KML and GeoJSON are text-based formats for sharing data. So you can open them up in a text editor. And the reason why that's cool for the web is because the web loves to share things. HTTP actually stands for Hypertext Transfer Protocol. And so the web's already set up to transfer pictures and text around a lot of times. So we'll talk about that more next week. Okay, and so that's open data formats. And we also have open specifications for web services. And that gets into what I was talking about earlier. That's the standards that set up and say, okay, a request for a map looks like this, and a response looks like that. Okay. So like, there's a document that says that a request for WMS needs to look like this. Okay. And there's a document that says a request for a tile service needs to look like this or something similar. Okay, so that's a open specification for map services. Now sometimes it can be free, or not free. Sometimes it can be open, but not created by a standards committee, created by a company. So it's like that's actually technically how shapefile was created. So ArcGIS said this is the format for looking at data in ArcView. It's going to be called a shapefile. Okay, and eventually, when everybody else started creating open source software, they said, well, let's just use shapefiles because everybody's already using shapefiles. And then eventually, ESRI said, okay, by the way, I know you've already figured this out, but this is how to create a shapefile. So ESRI came up with a standard. That standard was eventually adopted as the de facto standard for lots of programs. Well, the same thing happened on the internet, or is happening. So we have this WMS that was created by committee. We also have what's called the ArcGIS REST specification. And we'll talk about what REST means. It stands for Representative State Transfer. You don't need to know that right now, but we will talk about that. Anyway, it ended up being a very good way to share information. And so that's the way that the ArcGIS specifications have been adopted, and they're published. Okay, so ESRI says, hey, this is how you share. This is how we share data. So if anybody else wants to share data the same way, they can. Some people have done that. The only drawback to that sort of approach is that the company is free to say, oh, we're going to change it, or we're going to change it again, or we're going to change it again. Okay, it's not a horrible drawback, but it is a drawback. All right, and then also, in addition to these two types of open standards, we can also have data itself that's open and freely available. And sometimes that means that it's shared using an open standard. Sometimes it just means it's freely available for download. All right. That was more than I actually planned. I guess I took longer to talk today. So that lasted the whole time that I usually talk. And hopefully in the future it'll be a little more interactive. I tried to bring all that into a nutshell, the introduction to the course. So what we're going to do over the coming weeks is to hit these topics and to really study how to do these things individually, week by week. And so we're gonna start with the client, and as I said, progress on to creating map services and running the back end. All right, does anybody have any questions up to this point? If you like, we can just not take a break, and I can introduce what I want the assignment to be, which will take about 10 minutes. And then the assignment for this week is, like I said, it's not something that you need to stick around for, because it's just you watch a video and make a comment on it. Because we're not quite to we haven't introduced anything. So does that sound good? Just spend 10 more minutes, and then you all can go home or ask me questions. Okay, so that way, let's go back to the course materials, and you go to the assignment. All right. So for this week, you're going to just watch a YouTube video. The YouTube video does take about 45 minutes. Okay. So you watch the video. It's a talk given by Paul Ramsey. Paul Ramsey, it says a major contributor post-GIS. He actually, he's actually the leader. He owns the company that supports post-GIS. A lot of these open source software packages actually have a company behind them. For example, the one that we're going to use for this course for web mapping, I'll just go ahead and type it in. It's called Leaflet. I'm going to hit it. This is the homepage for Leaflet. So we've already shown you we can make these kind of maps. Okay, we're going to use Leaflet to create our maps in this course. And Leaflet is actually supported by this company called Mapbox. And Mapbox is a company, and they sell services. So if you want a cool web page or a map on your web page, or you want the ability to host maps, they do that sort of thing. Okay, but in order to have a company that can do this, let's go. Oh, I'm using the wrong mouse. So I'm going to go to Mapbox's website. So I go to Mapbox, and in order to have a company that can create maps and host maps, there's they get all these different kinds of maps that they host, and you can use these different base maps. In order to do all that, they had to create a window that has a map page on it, and so they created Leaflet to do that. And so it's supported by a company, but there are people from outside the company that contribute to it and help it to grow. And it's a fairly simple one. It doesn't have a lot of bells and whistles, and it's really one of the really cool things about it is that ESRI has written an extension so that you can use ESRI web services and you can use open source web services. So that's one reason why I like to use it, because it's simple, it's really small, and ESRI kind of supports it. They say, hey, you can use Leaflet, and so it's a good one. Now, when you get out in the real world, you might use a different one. But Leaflet is a widely adopted, used one. An older project is called Open Layers. For example, TriMet was using Open Layers. This is using Open Layers. I used to use Open Layers a lot, but now when I choose open source, I go with Leaflet. So that is another drawback to open source, I guess, or another challenge, is that sometimes projects get put on the side burner and another project gets used as the main project. So we're kind of in the transition where Leaflet is used more than Open Layers. But okay. So you're going to look at that. He's going to make some arguments for using FOSS over commercial tools. And keep in mind that he's coming from a perspective where he's making money on the free and open source software. So it is from his perspective, probably, I don't know if there's ever been a talk by like Jack Dangerman talking about how awesome ESRI is compared to open source software, but if there was, that'd be a good one to watch too. So you need to read this over, and then you're going to look over these three web pages. I did include the open source technology and ESRI web link. ESRI does attempt to work well with open source, and that's really a neat thing, in my opinion, that they work well with those. I think they see it as an opportunity to kind of bridge the gap. Since they have their own consulting piece of ESRI, they can say, hey, our software works with open source, so if you want to use some open source software and our software, you can hire us to support you. So they're making money on both sides of the coin, which only benefits all the users, I think. All right, so you're going to make a post on the discussion forum. That's right here on Blackboard. So if you go to Blackboard, you go to discussions, there is a forum called the Lesson 1 Assignment Forum. Now, you need to answer all the questions on your own first, because once you make the post, you won't be able to change it. Also, you won't be able to see anybody else's post until you make a post. That makes it fair, so that you can't just say whatever somebody else said. But generally, I'm pretty flexible. If you want to have discussion with somebody in the course, that's fine. But just don't post the exact same thing. But anyway, so that's how this forum is working. You have to post there. Once you post, you can't change it. And this will be your first assignment. And really, this is the key here, that you'll be graded on the depth of the arguments you put forward in your response, and not your opinions towards free and open source software. So you don't have to say that FOSS is the greatest thing on earth. In fact, you can say it's not, and you can make an argument against it. Okay. So you have to answer the questions here. Okay, so these are the questions that you have to answer. If you answer each one, you should be fine. I picture this maybe being a paragraph or two. Okay, when I say depth, I don't mean that you write a 6-page paper on it. Write a paragraph or two, and you'll get full credit. Again, this is an early assignment. So as long as I can tell that you watch the video and you make a coherent argument, you'll get full credit. But you do have to also write at least one response to another student's post to receive full credit. Okay. All right. Anybody have any questions about that? I got to get used to talking for this long. Okay.
We'll submit two separate things.
Right, but you won't be able to reply to anybody else's post until you post your own post. And this is due. So you need to have your post done by the next time we meet, and then you can have another extra week to respond to somebody else's. Okay? Just so that you don't have to go back on there every day and check and see if somebody posted, because it shouldn't take you much long to respond to somebody else. All right. I was thinking of going through some of the introduction to HTML and JavaScript, but that really will fit in better next week anyway. So we'll just leave it at that. No lab. Lots of classes don't have a formal lab on first meeting time. All right, so that's the way we'll leave it. If you have any questions, let me know. I am going to try to figure out if I can get down to the coast more often. One thing I forgot to mention is that I will be traveling a couple of times this semester, just once or twice. And on those weeks, it will be, I record all the lectures. So I'll just record the lecture beforehand. Okay, just all be recorded. Kind of like kind of like if it was a web course. You can email me at any time, and that's it. Okay. I will put them on Blackboard. So if you see, let's see. So now, right now, I can hit stop broadcast.